right, so we're going to do the next, well, they're not the next two, but two sections, 9.4 and 9.5 next, which covers the method called elimination. And as I said earlier, if you want to solve a linear system, there's basically three ways to do it. You can either graph the lines and see where they intersect, or you could use the substitution method, which is what we did last. And then there's the third method called elimination. And substitution and elimination are both algebraic methods. It means they don't involve graphs. The basic idea is, here, let me go ahead and show you by example. Actually, let's go back to the right example. All right, so if you have a system like 5x minus y equals 12 and 3x plus y equals 4. First of all, what you'll notice is that these two systems are in standard form. So you want to make sure equations are in standard form. Standard form is ax, you have your x term, plus by. Now, plus just means, b could be negative, so this could be a minus here, but you have your x term, then your y term, and it equals the number on the other side. So these two lines are in standard form. That's different from the substitution method where you have to take one of your equations and solve for one of the variables. Now, we're going to take our two equations and we want to basically add them. We're going to add and eliminate one of the variables by adding. So I'm going to say, second star, the goal is to eliminate, hence the term elimination, is to eliminate one variable by adding the equations. I always add them. You can subtract the equations, but what I've found is when people use subtraction, they almost always mess up the signs. So it's safer, in my opinion, just to always add them. Now, if you look at these two here, if I were to add these two equations, like this, just vertically, so we're gonna add, I get 8x plus, now negative y plus y is gonna make 0. So those are gone, equals 16. These are already set up to eliminate one variable when you add, so that's really convenient. So now we just basically have 8x equals 16, so divide by 8, of course, and x equals 2. We've eliminated, basically by adding these two, we have an equation here that has the y eliminated. Y is eliminated, and you can solve it if it's only one variable. Okay, so now I have x is 2. That's half of our answer because we need, this is going to be a point, basically. We need an x and a y. To find the y, you're going to plug the x into one of the two starting equations. So to find second variable, now I could have eliminated the, sometimes you eliminate the x first, then you're finding y. So it just depends on what your equations are. But to find the second variable, whatever it is, plug the value, meaning what you just found here, plug this number into either original equation. You'll get the same answer, it won't matter. So neither looks particularly easier than the other one, so I'm just gonna pick the first one. So 5, in place of the x, we're gonna put a 2 minus y equals 12. 10 minus y equals 12. Of course, we're solving for y, so minus 10 minus 10. Negative y equals 2. Now I have to multiply both sides by -1. So y equals -2. That makes my answer 2, -2. And you could check. So let me do a check here. And you're going to plug this point into both equations. It has to work in both equations. If it works in one and not the other, then that doesn't count. So let's say we're going to plug it into the first one. 5 times 2 minus y. Now the y is -2 equals 12. 10, this will be plus. 2 is 12. And basically that's good enough. I think 12 equals 12. We can see that. Okay, now I'm going to check it in the second one. 3 times 2 plus -2 should equal 4 if all went well. 6 plus -2 equals 4. 4 equals 4. So we're good. All right, let's do, yeah, I think I can do one more here. This time I'm not going to use up as much space, hopefully. So example 2. Let's do, okay, I think I'll try this one. 6c plus 7d equals -15, and -6c plus 2d equals -12. All right, now to solve, so I'm going to look at them first. And remember, the goal is to add these two equations and eliminate one of the variables. The way the equations are already structured, adding them will automatically cancel the c, because this has a 6c, this has a -6c. Those two are going to add to 0. I don't have to really do anything there's nothing I have to do, at least at the start, and you'll see what I mean in a minute. So, plus they're both in standard form. That makes the c's line up, the d's line up, the numbers line up. Adding these makes them cancel. And then I get 9d equals -27, dividing both sides by 9. D equals -3. Okay, so now I'm going to go back to one of these two original ones, plug in my -3, and get my answer. So I'll go over here and do it. 6c plus 7 times -3 equals -15. 6c plus -21 equals -15. Add a 21 to both sides. 6c equals, so that's going to be 6. And of course, dividing by 6 gives us 1. Now my answer, writing this as a point, remember how it's alphabetical, it's going to be C, D. So it's 1, -3 is the answer. And I'm going to do a little check here. so first equation, 6 times 1 plus 7 times negative 3, that should equal negative 15. 6 plus negative 21. Yep. Okay, we're good there. And then testing in the second one, negative 6 times 1 plus 2 times negative 3 should equal negative 12. Negative 6 plus negative 6. Yep, negative 12 equals negative 12. And I do want you to check these because it's, you know you have it right, and it's really good on a test to know that. So, all right, let's pause here.